Good evening, welcome to NMS. Let's answer the question, does long-term fasting actually lead to greater muscle loss? And I guess it's a really important one because a lot of people do long-term fasting and they feel like it's an actual health benefit, but is it really a health benefit? So let's have a look at it. So what happens in long-term fasting? Well, long-term fasting and or severe energy restriction leads to increased amounts of muscle loss relative to fat loss the longer the fast continues. But under certain conditions, muscle loss can be minimized. What does the literature say in terms of mechanisms? Okay, so what happens in a 10-day fast? Now, this was a study done on a 10-day fast in healthy humans. In the study of a 10-day fast, subjects lost on average 7% of their body weight. Okay, approximately 40% of that fat mass was fat, and 60% was actually lean tissue loss. That lean tissue loss, look, that's going to also include glycogen and water, as well as actual muscle tissue. Okay, so it's not all obviously muscle tissue, but a large amount of it's probably muscle tissue. And the longer the fast extends, obviously that's going to be worse. There was also a loss of metabolically active tissue. Okay, that's obviously the tissue in the body. So the body is not just breaking down muscle, but protein of different varieties. So what happens in a 12-day fast with approximately 250 calories per day? In other words, probably just eating a small amount of food just to minimize feeling excessively hungry. So a study of roughly 12 days of very low calorie intake, 250 calories, found that skeletal muscle volume dropped only modestly, and they say modestly in the study, 5.4% in calf muscle. Now, 5.4% of muscle is actually still substantial, okay? So that means that it could have been 5.4% in the rest of the body as well. So a lot of the losses was muscle glycogen and associated water, and not necessarily loss of contractile proteins. We'll talk about why that's difficult to sort of assess later on. Muscle performance, strength, aerobic capacity was mostly preserved. Now, I've got to be honest with you, I've seen people that do fasting, a lot of them don't do exercise when they do it. So how would you be able to test this sort of theory? And what sort of strength tests were they doing? I can't actually find what sort of strength they were actually doing to assess that. So what happens in a 72-hour fast? Well, in healthy men, after 72 hours of fasting, there was significantly increased phenylalanine, which is an amino acid, and that was released from muscle, which indicated net protein breakdown, reduced activation of mTOR signaling, and reduced downstream protein synthesis signaling. In other words, the body was in net protein breakdown. It wasn't actually producing proteins. Okay, so mTOR was suppressed, and obviously muscle protein breakdown was actually happening. So in rat studies, animal experiments in obese versus non-obese rats showed that in early phases of fasting, obese animals actually lose a higher portion of fat versus protein than lean animals. But as fasting goes on, lean mass protein loss becomes more substantial. In other words, if you've got large amounts of body fat, and obviously in a rat study, we would assume that it'd be very similar in a human trial. You are going to lose more fat at the beginning because you do have more fat to lose, and the body is not going to be fearful of losing that. But obviously, you've got to remember that muscle glycogen is important, and glucose is important, so you're going to break down some protein in order to go and create your glucose. So why muscle loss increases over time? Well, glycogen depletion happens in the first stages. So early weight loss is mainly water with glycogen. Because of that, lean tissue loss isn't all actual structural muscle, and longer fasting reduces signaling for muscle protein synthesis through downregulation of mTOR, as we've already said. So this increases the breakdown of proteins for gluconeogenesis. That's the conversion of amino acids into glucose, and ketone bodies as fat oxidation increases. After some days of fasting, once ketone production is established, there is a shift to using more fat, and the brain and other sort of organs can actually start using ketones, but there isn't a complete reduction of protein breakdown. There is only a reduction. There is only a small reduction, okay? So it's not complete switch over to fat. You're still going to break down some protein because some organs still actually can only use glucose for energy. So the proportion of muscle to fat loss decreases, but never zero. So what do we know about this? And obviously muscle versus fat loss over time. In a 10-day fast, approximately 60% of the weight loss was lean tissue, 40% was fat, as already mentioned. In longer fasts, greater than 10 days, muscle loss continues, but at a slower proportional rate as fat becomes a more prominent fuel source, especially once ketosis has actually been established. Animal data supports that in higher fat reserve individuals, relatively more fat is lost earlier, and muscle loss is relatively less in lean individuals or later in fasting. Muscle loss is also much worse. Okay, so many studies have actually. This is basically the problem that we've got with, I guess, doing these types of studies. A lot of the time, you can't be doing a long-term study on human beings, but if humans are doing it and they're willing to go and obviously put themselves into the study, then you can go and take their data from them. Okay. But it's obviously going to be a little unsafe to go and do long-term fasting studies. So many studies have small sample sizes. They're hard to isolate pure muscle protein loss versus losses due to water glycogen. Okay, individual differences such as age, sex, baseline fat mass, protein intake, and physical activity make a difference. Now, when I say protein intake, obviously we're thinking long-term fast, not eating at all, but don't forget in the trial with 250 calories, probably a lot of it was coming from protein. Very long fasts in healthy people are rare. Okay, so look, a lot of people will not do much longer than, say, there's intermittent fasting, but then 1, 2, and 3 day fasts. Okay, so a lot of the time people just cannot handle the actual pressure of doing a long-term fast. Hunger starts to take over, and a lot of the time the body is really trying to stimulate hunger and trying to get the person to eat. Many studies do very low calorie intake and not necessarily fasting. As you saw from the 12-day study, 250 calories per day. So here's a summary of what determines how much muscle is lost. Several factors influence the ratio of fat versus muscle loss. Someone with more fat reserves will obviously have more fat to lose, so muscle loss proportionally tends to be less early on. Protein intake when refeeding or during periods when feeding is allowed, adequate dietary protein helps preserve muscle mass. Okay, obviously that's more sort of your intermittent fasting. If you're doing long fasting, of say 10 days, obviously you're not supposed to be really eating anything within that 10 days, just drinking water. But I do believe some people actually do sort of periods of fasting, eating, and then fasting again. Resistance strength training helps preserve muscle mass even during fasting or calorie restriction. Here's the take home on that one. Obviously, if you're doing resistance training, you're not going to be able to train at a high intensity level without carbohydrates. Okay, and if your body's not producing carbohydrates, your endurance, especially for strength training, is going to be very much diminished. So I very much doubt that you're going to be able to do much resistance training whilst on a heavy fast, pretty much 0 calories. The longer the fast, the more risk of obviously muscle protein breakdown, scaling up once initial glycogen water phases are passed, but also scaling down a little bit once we start using ketones for energy. Okay, here's the big problem. Older individuals tend to lose muscle more easily and may have less capacity for resynthesis. In other words, once it's lost, it's gone. Now, I'm going to give you my take on this, guys. I don't push fasting. I'm not a fasting person. But if someone says to me, can I do, say, an intermittent fast? I'll say, yep, that's fine. But we need to get your protein intake at a level that actually preserves muscle mass. Okay. The thing is that a lot of people do fasting for a health benefit, but you've also got to keep this in mind. If you're doing it for a health benefit, but you're losing muscle mass, sarcopenia, and especially as an older individual, it's going to lead to health problems, okay? And those health problems obviously can be loss of functionality, loss of ability to use glucose, and obviously, you know, you're going to put the weight back on, and most of it's going to be fat gain, and that's also going to make the individual even less functional. So keep in mind, guys, that if you're doing fasting for health, it's to go and lose body fat, okay? And I would suggest that you don't do any more than, say, an intermittent fast of about a 16-8 window. People talk about doing a different fasting window. Look, if you're a very heavy person, that may work, but you've got to keep in mind, guys, that the long-term benefits of fasting are outweighed by the muscle loss and obviously BMR diminishing. So keep that in mind. I'm going to leave this video only on YouTube, but I'm going to cut little parts of it and probably put it on TikTok and other platforms. Thanks for listening, guys. And if you can, subscribe, like, comment, and share. Thanks for listening.